Okay, so today you're going to be doing an activity on human health risk assessment. And so basically, we're going to look at some toxins that are commonly found in water and food and some of the things that we do. And this is so what the EPA does is they will assess a chemical or toxin, and they will assess the likelihood that humans would ingest it and how often are they likely to ingest it and over time. Basically, they go through and they create a life risk assessment for each chemical. And if the risk is not too bad, and not a lot of people would likely be affected by it, they deem it okay for it to either be in water, be in food, or whatever. And so every single time there is a synthetic chemical or something is made, it has to go through these processes of testing whether or not there's a risk to humans. Sometimes the problem is that we don't know what the risks are to humans, and so sometimes we don't find things out until after they start causing problems. But basically, um, some toxins, will appear in areas of a higher concentration for a particular reason. Like there could be lead in the water in certain places where, it's higher than normal, or in some sort of groundwater pollution or well pollution. So that's where, we see issues, and we saw it with PCBs in South Park. I told that story. We saw it, with the Love Canal, or whatever, and the toxins that were there that were causing birth defects. We saw it with, um, you know, asbestos in certain parts in certain areas. And so what we're going to do here in this lab is you're actually going to calculate a risk assessment based on these are just made up. They're hypothetical wells that were drilled, and so what you're seeing is the concentrations of a couple or a few different compounds. So you have benzene. Benzene is very common. Benzene you would find in natural things like fire, smoke like in fire or volcanoes, but it's also in some man-made things like cigarette smoke, gasoline. And so you can probably understand how that would easily get into groundwater or in waterways or maybe in the things that we eat or drink inadvertently. And so we want to see at what levels are people being exposed to this, and does the EPA or somebody need to come in and clean this up? Another one is carbon tetrachloride. Carbon tetrachloride is in oils and fats and is often found in like lacquers and varnishes, like in paints and stuff like that. Oftentimes, people don't take care of their hazardous waste. Here in Hamilton County, we have a nice facility that we can take things to that will discard our hazardous waste. But a lot of people might be too far or inconvenient, and so they end up dumping paint down the drains that's not used, or just throwing away old paint cans, or lacquers or varnishes, and it ends up into our waterways and then pollutes our groundwater. The third one is methylene chloride. Methylene chloride is found in aerosols, sprays, spray paint, any of those. And so this oftentimes ends up in our waterways too, as things erode over time. They end up getting into our groundwater systems. And so all of them they're all carcinogens, and they all cause cancer. Benzene is linked to cancer in the blood or leukemia. And then the other two are linked to liver cancers. And so you're gonna do the math here and figure this out. So basically, you're gonna read this portion of the activity, just as a little introduction to what the EPA does and sort of why we're doing this. This is not a lab, so it's just an activity, even though it says like a purpose and procedure and stuff like that. This is going to be treated as an activity. But you can see here it goes through 30 groundwater wells in a rural area and that have been contaminated with 3 chemicals from a previous industrial facility. And then so these have all been labeled as carcinogens based on evidence from human and animal studies. And then so you're going to do the work on the following page. So it goes through, it pretty much walks you through it. It's pretty self-explanatory here what you're going to do. Basically, there's a formula that's required. So the LADD is your lifetime average daily dose of a particular carcinogen. We take in a lot of things that would be dangerous to us at higher concentrations, but because they're such low concentrations, they don't have a great enough effect on the greater population. So they calculate this, and basically it's whatever this 95% of UCL of the mean UCL, and then that it goes as your concentration in water, assuming we get it in our water. The ingestion rate, they average that people drink about 2 liters of water per day for 350 days a year. Maybe you go, 15 days. These are all averages, and that you'd be exposed to this for 30 years because adults live on average in their place of residence for about 30 years. The average body weight of an adult is 70 kilograms, and then the average timing, so 365 days a year times 70 years. So over the lifetime, what's the likelihood of them developing cancer? And you have the same quantities here for a child. Children just don't tend to live in the same house for as long as adults do, and they weigh less, so the numbers are a little bit different. Now, we have given you the concentration in water for all 3 of these, so you don't have to worry about this. But the math basically says you multiply this times this times this times this and divide it by this times this. And so that's what's going to end up going down here in your data table. All of this needs to go into your lab notebook. So you see here we give you the 95% of UCL of the mean for all 3 chemicals. And then you just got to make the calculations. Lifetime average daily dose, the formula is up here at the top, in which you'll plug everything in and find the number. When you get a number right here, basically that is the amount of milligrams per kilogram per day that an adult would get on average daily. And the same thing with a child. And you're going to have to do this for all of them. And then the last box here is the excess lifetime risk. Now, what the excess lifetime risk means is it's not going to have a unit tied to it. It's going to be just a number. And that value is going to be the amount of people that chemical would increase in terms of cancer liability. So for example, if I got, and it explains this above in the directions, if I got 0.01, for my excess lifetime risk, I got 0.01. That's 100th, which means that 1 out of 100 adults would increase their risk of cancer, or I should say 1 out of 100 would develop cancer directly related to benzene. So 0.01 would be 100, so it would be 1 out of 100. That's really high. The EPA states that 1 in a million is acceptable for chemicals that would cause cancer. So 1 person out of a million would develop cancer relating to that chemical. That's acceptable. So 1 out of 100 is not acceptable. And so there would need to be some sort of remediation or something would need to be looked into as the water quality here as to fixing this or why the water quality is like that. You're going to get decimals here that are very small, and so you have to look at the decimals and then write. This will be, you can write this as 4 out of 1,000. 8 out of 10,000 adults or something like that. Some sort of ratio of people who would likely develop cancer directly related to benzene and carbon tetrachloride and methylene chloride. And same thing for kids. And we look at that risk assessment. 1 in a million is what is considered safe. So obviously we know that these have been contaminated, so you're probably not going to see anything safe here. And then you're going to go ahead and answer these questions afterwards based on your analysis. If you have any questions, please send me an email or a Canvas message. This will be due next class, so on Monday or Tuesday, depending on when you are viewing this. Thanks.